In recent years in the fight against malaria, vector control has been a phenomenal success. Since 2000, 663 million malaria cases have been prevented. And of these, 78% are due to the use of insecticide-treated bed nets and indoor residual spraying. But there's a growing problem. Mosquito resistance to the public health insecticides we're using now have been reported in the majority of malaria endemic countries. This means the huge gains the world has made in reducing malaria deaths since 2000 could quickly be reversed. So what's caused this problem? Up until now, no new public health insecticides have been introduced for bed nets and indoor residual spraying since the 1970s. So we've had to rely on just 4 classes of approved insecticides for indoor residual spraying. And only one of these, the pyrethroid class, is approved for bed nets. The problem is, the longer and more widespread a particular insecticide is used, the greater the chance of mosquitoes developing resistance. And that's the stage we've reached in Africa. We are facing an ever-growing army of insecticide-resistant mosquitoes year on year. New insecticides are urgently needed. The good news is that IVCC, together with its main industry partners and funders, have been working hard on a range of solutions, and in particular are focusing on 3 important and complementary areas. The first 2 parts of this involve insecticide development, repurposed insecticides and novel insecticides. And the third part is deploying the insecticides as part of a robust resistance management or IRM strategy. These 3 things are critical to long-term vector control and malaria eradication, and here's why. Repurposed insecticides are based on insecticides already used in agriculture, so many of the regulatory and safety requirements have already been met. Development is focusing on introducing these insecticides in formulations designed for vector control, allowing for a relatively quick and less expensive delivery of new public health products. It may look simple, but not all the insecticides available are suitable for vector control. For example, if they've been used across agriculture for a number of years, it's important to check that mosquitoes aren't already resistant to them through local exposure. So, although recent successes in this area have been extremely encouraging, in reality the number of options for turning agricultural insecticides into vector control products is limited. More insecticides are needed if malaria eradication is going to be a reality. For sustained vector control and malaria eradication, the answer lies in the discovery and selection of brand new insecticides that have never been used before. At IVCC, we've been working towards this goal since 2005. But it costs far more and takes much longer to develop a brand new insecticide from scratch. There are many hurdles to overcome, and candidates will fail along the way, but ultimately the best will succeed. We've made some significant strides forward, but it will still take at least 5 years before safe and effective new products are available in the market. Both repurposed and novel insecticides are essential components of IVCC's product portfolio, as we aim to build a toolbox of products which can be deployed in a sustainable way to combat the ever-present threat of insecticide resistance. How this toolbox of insecticides is used will play a major role in how we eradicate malaria globally. This is why the new implementation strategy is so important, as it will determine how and when the toolbox of insecticides are best used in a sustainable way, making malaria elimination a real possibility. A toolbox of different innovative insecticides will allow them to be rotated on a regular basis, used as mixtures, and used in a mosaic pattern across different geographical regions. By using this approach, different IRS insecticides can be rotated every year, so that mosquitoes will not be overexposed to a particular chemical. Mixing insecticides into a single product, whilst ensuring that the dose gives complete kill, will also reduce the chance of resistance developing as mosquitoes not killed by the first active ingredient will be killed by the second one. Using different chemical combinations across geographic regions in a mosaic style will avoid the build-up of mosquito population resistance. So, malaria eradication is a hefty challenge due to its complexity, but short and longer-term vector control solutions are making the idea of malaria eradication a reality. Achieving this requires the long-term commitment from our industry partners, and we are asking a lot from them, as the vector control market is of little commercial value to them. IVCC and other malaria eradication partners also rely on the long-term support and commitment of their funders to continue the goal of insecticide development for vector control. We are making great strides, but we cannot be complacent. Each new tool plays a critical role, and used responsibly, we have real hope that malaria will be eradicated once and for all. IVCC, Vector Control, Saving Lives.